Okay, so today we are going to talk about TokenFormer and patention. And I find this a little bit hilarious, but who am I to argue about it? So the idea is this. In a standard transformer block, we always have two main components. One is multi-head self-attention and the other one is MLP. As I have always said, attention is basically the communication mechanism where tokens talk to each other. The MLP is where the model actually thinks. It processes each token independently and adds computational depth. Now this design works extremely well, but modern machine learning models are getting extremely large and scaling them is becoming a real problem. Suppose you want to do something simple like increasing the number of channels or widen the model. The moment you do that, you change the architecture and suddenly you have to retrain the whole thing from scratch. That's insanely expensive. And the biggest bottleneck here is not attention. It is the token parameter interaction, which is done using fixed linear projections. Those projections are baked into the architecture. You change dimensions, everything breaks. So the natural question is, can we rethink how tokens interact with parameters? This is where TokenFormer comes in. The key idea of TokenFormer is actually much more radical than just replacing the MLP. What TokenFormer does is, it says, why are we using attention for token-token interaction but linear layers for token parameter interaction? Why not use attention for both? So TokenFormer replaces all linear projections with a new kind of attention called token parameter attention. Not just the MLP, but everything. Q projection, K projection, V projection, output projection, and the feed forward block, everything becomes attention. Here's how it works. The query is still the input token, but the keys and values are no longer derived from the input. Instead, they are learned parameter tokens. You can think of them as a set of trainable memory slots. So the token asks a question and these parameter tokens respond. This looks like attention, behaves like attention, but functionally it replaces what linear layers used to do. Now here's the important part. Because parameters are now tokens, scaling becomes incredibly clean. Instead of increasing width or changing hidden dimensions, you can just add more parameter tokens. That's it. You are scaling along a completely new axis, the number of parameter tokens. And this does not increase the cost of token attention. So the long context modeling of the large language models stay manageable.